Let us begin. I'm about to tell you the engineering quest that we had in Iguazio. This is something that we attempted, well, actually succeeded, to bring Kubernetes into our kingdom scroll, into Iguazio's platform. We had to write tools. We also had to fight a lot of battles inside and outside of the community and with the tools themselves. And we also had to apply a lot of magics to actually make this entire quest possible. My name is Eliran Bivas. I'm somewhat proclaimed tech junkie. I'm working for Iguazio. And as part of being someone, as a Joker developer, I had to assume all the roles that I currently previously defined as Lego figures. And yes, I do love Legos. And now that I have kids, it's not so weird that I have so many of them. Not kids, Lego sets. And I had the opportunity, a huge opportunity, to bring Kubernetes into the platform, into our platform. At Iguazio, what we are basically doing, we are a data platform. So everything in short, what we are doing is we ingest a lot of data coming in from maybe Spark streaming, or maybe Kafka. We have all kind of incoming methods of reading in data, even Hadoop as a legacy approach to many organizations. And once we get the data, we enable that every user in the using our platform can simultaneously query the data or work with it, maybe do something with it, maybe run some TensorFlow, maybe do Spark analytics, Presto querying, and so on. So when we looked at cloud native, when we first developed the platform, our data platform was cloud native. It was resilient. It has HA in mind. It was easily being scalable and easily being managed. When it came to having all those data services available to the user, we were on a legacy approach, we'll call it. We're using a lot of scripts and Ansible to basically install Spark, install TensorFlow, install all the other tools that we had, and it really didn't fit with the entire agenda of being cloud native. We were partially cloud native only on the data platform. So when we first looked at what our customers were using and what they were doing on their own, we kind of tried to figure out what we should do. So first, most customers we identify were trying to build it on their own. They bought the hardware, wired everything, and tangled everything actually, and they ended up doing late calls at night that some service has failed and what to do with it. It requires a lot of attention and it requires a huge amount of DevOps personnel to just maintain a simple service. Next, they move to the cloud. This is the simplest way for you to run data services. You basically give your data and a huge paycheck to any cloud vendor, and now you have someone else managing your services. You work with the data, and others are actually managing everything for you. Now, as the paycheck grew bigger and bigger, companies decided that they want to have some kind of measurement of control, but still enjoy the benefits of the cloud. The benefits is, of course, someone else manage it, someone else making sure that your data services are actually highly available, and they can actually work with the amount of load that you're trying to hammer them. This is where cloud native comes in. It's not really shifting. It's basically saying, this is a black box that has all the promises of a cloud, but you can run it everywhere. You can run it on your own. Feel free to do it. You can run it in the cloud, and you're now no longer a cloud. You don't have a vendor locking. You can shift it all around because it's the same black box that you move around, and you have the same experience no matter where you deploy it. So if you look at a specific services mesh from Amazon, which is the leading cloud provider, we see this data offering, this common services. Of course, this is Amazon. Azure has something identical, and so does Google. Forestry, this is the object store. We see Elastic MapReduce for analytics services and AI, of course. It's the latest service by Amazon to do TensorFlow and analytics on your data. We see Athena, which is a pre-managed Presto service to query the data. Kinesis, of course, is something like Kafka, but it's actually not. It's a streaming solution. And of course, something quite unique to Amazon at that time, they were the first to introduce it, it was the Lambda service. Basically, all of these services are serverless, but this is a function as a service. You don't even care about your application, you only care about the function itself. So looking out on that service mesh, we had some understanding on what we would like to offer back to our customers. And we had a lot of building blocks, a huge amount of building blocks. Now we knew kind of what is the service mesh we want to offer, but how do we manage it? How do we actually manage multiple hosts? How we handle failures, and not just stating them to our customers saying, oh, you have a failure. No, we need to handle it for them. How do we handle multi-tenancy and multiple users within that tenant? How do we create isolation? How do we create better security for that application? Reminding that in Amazon, you actually shared the hardware, but you feel secure. We wanted to provide the same experience for our customers. So everything that we saw in Amazon or in other cloud vendors, this is something our customers liked, and then didn't like all the other stuff that they switched to cloud provider at the first place. So first we chose our future scheduler, and the obvious choice here was, of course, Kubernetes. Kubernetes is cloud native by nature. It has a chain in mind, and it has resiliency and scale in mind. Everything that the cloud native movement believes in sits in the Kubernetes guidelines. And we wanted to manage data services. We didn't want to manage our host perform. We didn't want to manage how a specific container is running. We wanted to manage a system as a whole. And when you choose Kubernetes, this is basically the only way to go. Now, when you first try Kubernetes, you have a huge list of concepts that you have to understand. You have to understand which is which and when to use what. Our services sometimes utilizing pods, sometimes utilizing a daemon set, a deployment, and when to use config maps, when to use secrets. And as you progress with the versions and your deeper understanding of Kubernetes, you actually add new objects. They are constantly adding new concept into the system. You want better network isolation? Great, there is network policy. You want better security? The first step is using pod security policy, and going on and on and on. I couldn't fit all the objects that we are currently using, but you have to understand that you constantly have to relearn everything when each version is progressed. And the entire cloud movement actually defines new concepts all the time, because Kubernetes is de facto the cloud native scheduler. There is no other dominating scheduler in that area. So every standard that the cloud native movement defines go directly into Kubernetes. So at Iguazio, we decided to not just look at the community, just be part of it. So we participate in a lot of discussion groups in network, storage, and serverless standards. So as the community progressed, we were given a voice to step in and declare our requirements and our understanding on the market. Now, the best way to work with Kubernetes, actually, it's CLI Tool, which not many people like, but it's essentially to work with. There are basically around 60 main branches of commands, and down the line there are hundreds more of subcommands, flags, switches, and what else. And by trying to monitor and working with a Kubernetes cluster, you have to master the kubectl. This is the CLI tool for Kubernetes. You can, of course, find out how the cluster is actually performing, what is being deployed, what is the content of a config map, how to actually look at a specific namespace. Every aspect that I showed earlier in the objects, in the previous slide, this is something that the CLI tool provide you access and ability to alter, and maybe add new. And when you first try to understand what's happening in the cluster, you're running several commands a day just to understand what's happening. Next, there are YAMLs. This is the hello world version of Kubernetes, but it essentially means nothing. This is not something you actually run. There are huge amount of YAMLs. They are endless. And when you actually define a data service, a real one or a real application, your YAML doesn't look like this. It has mount points, it has environment variables, it has various configuration items, and so on and so on and so on. And the YAMLs are basically gonna overrun you. So instead of being overrun by YAMLs, you have to find the right tool for the job. And there is a tool for that in the Kubernetes toolbox, which is Helm. Helm is basically a blueprint for deployment. It's a community-driven project, basically saying, here's how to deploy a specific service. This is a blueprint, run it. When we first found out about the project and participated in it, it was lacking at best. It wasn't ready for production use. So again, we didn't just look at the community, we tried to step in. So we contribute a lot of code to Helm, both to the tool itself and to the repos. We fixed a lot of charts. We added a lot of missing features to others. And we even found out that there is no blueprint for running Presto in a large-scale environment. So we contributed our own chart to the repo, and now it's the official one for running Presto in Kubernetes. Now we have something that feels like a cloud. By running everything in Kubernetes using Helm, our S3 storage is now Iguazu-based or Hadoop-compliant file system. We have an elastic MapReduce service that actually sits directly over Spark, Hive, and HBase. Everything is being managed in Kubernetes. We have TensorFlow adapters, we have Presto adapters, and of course we have our own notion of streaming, just like Amazon does. But we do also have support for native Kafka. If you have a Kafka cluster, go ahead, use it. We have adapters for you. Everything is being managed and deployed for you. You don't have to manage anything in the system. But when we offer this main data services, we found out that we were kind of lacking. We couldn't find anything suitable for the Lambda architecture. We wanted to have our own function as a service. And we looked at other open source and community-driven solutions like OpenFaz and Kubeless, but they are kind of lacking, and we didn't find them quite suitable for a high-performing platform. So when we looked at serverless, which is a great direction in the industry, we found out that it's what customers really love, because it's easy to deploy. You don't have to manage YAMLs. Everybody hates YAML, and everybody hates Docker files as well. And you don't have to manage them now that you're using serverless. It will do the auto-scaling and management for you, and you can actually write in any language possible. The environment is polyglot by nature now. You can write in Node, you can write in Go, Java, whatever you like. But this extremely great benefits come with a huge pitfalls. And most important one is the performance. They are usually very slow performance. And most serverless frameworks only operate on HTTP. which it's kind of like writing a webhook, and we don't just work with webhooks. We sometimes want to work with Kafka, maybe RabbitMQ, and so on. And as the function become more and more complex, it's actually becoming much, much harder to manage them all. And it's almost impossible to debug. If you have any experience working with Lambda, trying to debug a Lambda function it's a tedious work. So this is why we decided, really looking at all those pitfalls, to address specifically these pitfalls. We wrote an open source tool called Nucleo. Nucleo is a very high performant serverless framework. I'm not going to discuss about it because you can find a lot of information about it. But in short, again, we don't only support HTTP as entry bay. You can work with any type of invocation system. You can work not just on Kubernetes. This enabled you a better debug cycle. Everything you tested locally on your on your workstation is what's going to behave on the production system. Nothing is changed. We created Docker files for you. We created the YAML files for you. Everything that you require from a serverless framework is being given for you. It same goes for monitor events, logging, and everything that is missing in other systems. We came to realize this is the most important part when working with production environments. Next, now we have a serverless or function as a service, but we found out that the system can perform much better. And by doing so, we wrote another open source tool. And this tool works closely with Kubernetes to actually own the outgoing connection. Now, no matter if your services are using TCP or RDMA connection, we do the connection initialization for you, and everything coming from that wire on TCP or RDMA is being shared to your application directly. We have adapters already on our data services. Like we said, we manage the data services, so we have the adapters for it, and we basically run a daemon set that copy everything into the user the memory. So the application doesn't do any copy by itself, it's all resident within its memory. And if you don't have our adapters, some applications like TensorFlow don't have direct adapters, we have a flex volume, another implementation working closely with Kubernetes, basically having a shared memory again, offering a very fast data IPC for your application. This is a huge boost to our application performance, and I'm pretty sure, I hope that other data services will offer such boost, because it allows us to get a significant amount of increase in performance with reducing the overload of the entire system, because there is a sole TCP and RDMA connection working with the system. And again, everything is open source here, so besides our core data platform, everything that I'm showing is open source and completely available for others to use. By now, our offering kind of looks like this. I cherry-picked some of the data services that we currently utilize. Our data platform, a unified data platform, actually manages clusters of Kubernetes, everything working as a federation. Our Fuse adapters, our daemon that I previously mentioned that copies all the data to the user space memory. We have our own registry, logs collection, monitoring events, of course, and all those managed services that each tenant and each user within our environment works with and enjoy a very cloud-native solution. Not just the data platform, everything is now automatically being managed by our single platform, Iguazu's platform. Now, some lesson learned in during the time of migrating our services to our cloud-native environment. First of all, you have to read the manual. if I had 6 items, all of them will read the manual. And it's very important because I had a lot of stuff that people were trying to hack the cluster, and the manual said, this is not the way to do it, or this is the way to do it, or trying to hack a lot of items or services or YAMLs with very, very strange approach. Basically, read the manual. It's very long, it's constantly changing, but you have to understand which part goes where. You don't. Initially, we had someone using, instead of daemon set, they were using an attempt to do a slip in a container, or a job instead of, or daemon set instead of a job, and so on and so on. So again, reading the manual is very, very important. Next is community. Community. Kubernetes is driven by the community. Everything that I just mentioned is driven by community. It's open source, great. Most people that contribute to this community-driven application don't run it in production. So you have to pay attention what's actually being tested on a real workload. When we started testing stuff on a real workload, we found out that it's not production ready. So we had to contribute back. Like I said, we had a lot of influence into the serverless workgroup. We had a lot of influence on the charts. We had a lot of influence on Helm, and so on. We wrote a lot of tools to influence back and help the community. It's not something that you just say, there is a community behind it, I'm only a winner. You know, you have to constantly add and change and contribute back. You have to know the kubectl command line tool. If you don't know it, you're gonna end up trying all kind of weird solutions. Basically, it's in the tip of your hands. Just type commands, understand what they're doing, when to use the output modes in kubectl. And this is something that is very essential when working with Kubernetes. The next item, of course, is Helm. Don't try to write your own YAMLs. Don't try to bring another tool into the mix. Helm helps you a lot to manage all your data services. No matter how much they're complex, Helms are the best way and the best tool for the job. Now, number 5 is kind of obvious for some people, but I can't stress it enough. All the configuration should go to config map. A lot of people try to do, a lot of Python developers actually love to bring code into Python and then enforce it in, place it in the Docker file, and then there's no way to change it, and then do some hacks instead of just placing them in config maps. I even go further, and all my charts that you can investigate as they are open source also have the init scripts in config maps. All the scripts, nothing in the container besides the executable. The initialization script, all the modification that we are doing in the container are in the config map. We simply run that config map as an executable. And last, don't hack. Try to do it in the Kubernetes way. This is basically a cycle to read the manual. You have to do it in the Kubernetes way. There's a sole way to do it, and the entire community will tell you how to do it. Most of them are wrong, but you have to understand by reading the manual. And if you're tweeting about Kubernetes, don't write Kubernetes, write it like a pro. And final lesson, this is a topic for a completely different lecture. The line says, I need to monitor a Kubernetes cluster. Yeah, it is a very hard job. You need to understand what you're collecting and what you actually need to throw away. So this is something that maybe next talks. Thank you very much.